there, I'm Blair Johnson. I'm going to talk to you today about the mysteries of spatiotemporal meta-analysis. As a plan, I'm going to introduce you to this subject in the first part of my talk, give you a big picture of sorts, give you some examples of spatiotemporal meta-analysis. Then we'll move on to the actual methods, the nuts and bolts of the process. I'll follow with a few cautions because, well, no method is perfect, right? And then some conclusions overall, and I'll leave you with a couple of discussion questions at the end. Over on the right here, we've got one of my favorite paintings of Vermeer's Geographer, apropos for this talk. So as an introduction, okay, let's look at our big picture and the 7 steps of meta-analysis, which are all interrelated and require synergy, and you might have to go back to Go to repeat any number of steps because you'll learn stuff along the way. Where would geography or spatial temporal aspects be relevant to something like this? I would hope that you would do it right from the start. So as a goal for this talk, that's what I would say. I would hope that you would think about space when you're finding and selecting studies, because what if you use English-only searches? Are you going to restrict yourself to westernized nations that mainly speak English? I would hope that when you code studies, you're going to think about the context where the studies were done, okay? I'm not sure if geography is relevant to calculating effect sizes so much. I suppose you could have a geographical effect size. That's possible. And then we're also going to have analysis aspects and interpretive aspects that weigh into this as well. So you're going to have to do moderator tests for things that you code about space and time. And I suppose if you've got all that wrapped up in here, whoever follows you, whether it's your team or not, can follow behind and add whatever they want by going back to whatever step is most relevant for them. Okay, where did it all start, the spatiotemporal meta-analysis thing? There I was back in the mid-aughts, mostly doing meta-analysis of HIV prevention trials, the behavioral interventions, and I found myself asking, do the results match the predictions from prominent theories? And unfortunately, the answer was often not. And so I wondered what's missing. And I did something like that. And then I got an idea, which is that space and time were not in any of the prominent theories, and therefore they weren't also in the predictors that we were gauging from studies. We're missing community level factors. We're missing ecological factors. So that then produced a theoretical effort on my part. The network individual resource model, here's a little graphic of it. Basically, the idea is that networks and individuals are yoked and they exchange resources. It happens across time. It happens over lifespans. It can be momentary or chronic. We have different tangible and actual resources that are exchanged, and without individuals contributing to networks, the networks will go away. And without networks sustaining individuals, the individuals will also do very poorly. So all of that is wound together. It's really a theory of behavior change, of behavior and of behavior change, not just HIV risk and AIDS care. So we published this in 2010, and it's been out there influencing to some extent work that's been happening since then. It's been really behind my own thinking conceptually. It's like, well, if you want to think spatially, you've got to be thinking, well, what are the networks doing in the space where you are? Okay, so you could be naive about all this stuff. I mean, most people who have some aspect of space in mind will probably do some kind of naive geocoding. So, like, let's imagine that if all you needed was the altitude for your study. I mean, maybe you're studying exercise and blood pressure or heart health or something like that. Well, all you'd have to do is look up each location for each study and code altitude. But here's the thrust of the matter. There's lots of other stuff known: economic, social, physical, pollution, nutrition, and so many more things. And sometimes those things are correlated. That's a point I'm going to return to later. So if you do a formal geocoding, it's a flexible way to match known data from geocoded locations into your own database. And of course, probably, I mean, altitude isn't going to change much unless you've got an active volcano, I suppose, or an earthquake that creates a divide in the earth. But a lot of other things do change. We know cultures change dramatically over generations. So, and sometimes they don't so much. I'll also come back to that near the end. So better to match for time and space if you can do it, because studies are in the end distributed over space and time. So one of the first persons to point out that the temporal dimension can be interesting is Jean Twenge. She's been doing this for over 20 years now, popularizing what she calls cross-temporal meta-analysis. So here are two graphs from her meta-analyses. The one on the left is a narcissism graph showing that over time samples of, I think this is college undergraduates, have increasingly higher narcissism scores. And over here in this one labeled figure 2 is actually depression scores. So the MMPI actually has been scored as early as like 1938 or whatever. And this study came out around 2010, and so it had data almost up to there. The very same scale examined across time, showing depression levels going up again. Tells you culture is doing something wrong. It's very informative about generational changes, cohort changes. What you're seeing here are people at the very same, tested at the very same age of their maturation. And so if they differ, that implies the cultures, the cohorts, not the cultures, maybe the cultures too, but the cohorts are changing over time. Each generation doesn't quite match the previous. And another maybe more famous example yet is the Flynn effect, which is that in most of the world, intelligence tests have been rising in the general population over time and across generations. This is an amazing phenomenon. It's not completely understood yet, but here's a bunch of data all put into one graph showing that all sorts of types of intelligence are rising a lot over time. It makes you wonder when you time travel in history, maybe your advanced intelligence helps you to gain insight on those slow-witted cretins that came before you. But I jest. Our first effort to deliberately bring ecology or the culture to bear on effect sizes in a meta-analysis, the first spatial meta-analysis that I did was this one. This is spatiotemporal. And here we looked at whether community-level stigma, whites' prejudice towards blacks, might actually influence the success of HIV prevention interventions. So here are my co-authors, real quickly. And here's a way to show off where the studies were done. You can see that mostly African-American trials were done in major cities. There are some exceptions to that. The graph could probably be tweaked, but at least gives you the main thrust of the problem. And our results confirm the expectation. The better attitudes were towards African-Americans, the more success you had on the condom use effect size outcome. And in fact, if you look over here at the left, because this is a moving constant table, in communities that had, basically were only at the neutral scale. I mean, and I should say, we gauged whites' attitudes using the American National Election Studies database. So it was spatial temporal. So it's a thermometer scale, goes from 0 to 100. So if you're in the middle, that's neutral. Okay. Wow. I suspect neutral disguises a lot of negative variability, and we imagine. And a lot of research has shown since then that perceived discrimination and actual discrimination causes stress, and that gets in the way of any kind of behavior change you want to introduce. So that's the theory behind this. Okay? All right, another example. This is very recent, hasn't yet been published, but you can find a preprint if you follow this QR code over here. It appears that cultural sexism in the states in the U.S. Moderates the effects of psychotherapy for girls. And the very same thing like last time, this is the cultural sexism thing on the bottom, and it's been standardized so the 0 point just means the middle of the distribution. That doesn't necessarily mean neutral for sexism. Probably all the states are still sexist no matter where they are on the scale, just it's a matter of degree. But the very same thing, I mean, your reference line for the null effect is here, and in fact in trials for girls at least, that where the cultures can be characterized as extremely sexist, you get on average no significant benefit from the therapies. Whereas in cultures in the US that are relatively not, you get fairly large effect size over there. So here's an interesting bit of evidence that cultural sexism might moderate the effects of psychotherapy for girls. The boys not so much, although the focus of this paper was on girls, and I think that the story is really not told yet for boys. That very same meta-analysis also gave a nice map. This one shows the gray ones are where the trials are not. So you can see a few deep south places didn't get included, and a bunch of the far west. And then it also gauges the cultural sexism levels. And you know, I didn't say, but that came out of mostly Project Implicit, but also the General Social Surveys, a very large set of database. You know, a couple of million participants in that database at this point. It's profound what you can do when you get a database that large. But I guess in a figure like this, you could ask some questions, and this is what spatial meta-analysis is kind of like. Do the results generalize to states where no data were collected? In fact, I would wonder if maybe cultural sexism is one reason people didn't do any trials in the Deep South, okay? And I suppose you could ask the temporal question too. Well, maybe there are no recent data. What if the only trial in the state of Minnesota came from 1969 or something? Minnesota might be a different place today. And therapy probably has improved too. Okay, so we asked the same question about HIV prevention trials. Where did they take place? And so this is the first map that I ever saw available about where actual behavioral interventions were done in Africa. And we cast a broad map, if you will. It's all of Africa, and you can see that there are no trials above the equator. So it's all sub-Saharan Africa, pretty much. But you can see also that some places are not as well studied as others. Whereas a lot of other places have lots of trials. Look at all those over there and all of these bordering each other in these neighboring countries. So you can get a sense from a glance at a map where data are thickest and where they're thinnest, where we know something and where we don't know very much. Okay. And so there's, to put it another way, qualitative results from a meta-analysis can be highly useful if it's spatial, if you've been spatially aware. So to go on to more formal methods of spatial temporal meta-analysis, essentially 3 different steps here. There's geocoding. So you've got to find a way to know where every study was conducted. You need to use codes, formal codes, to join databases with moderator information, and then conduct and interpret moderator meta-analyses. So the paper where we put this most fully so far is in Health Psychology Review, and there's a QR code for it over here. So check it out. So, you know, you could geocode each study, and I just gave some silly examples perhaps in some of these, but stores, Lima, Peru is a pretty big city. Is that accurate enough for you? San Francisco also, you could talk about different places around it. This maybe points up some of the problems with geocoding. Northeastern United States is really vague for anyone who's lived in the northeast of the U.S. A large university in the Midwest is what some reports sometimes do, maybe trying to blind the identity of the authors so that review remains blind. You know, you guys, when you publish studies like that, put the actual place in the report when you publish it, okay? Please, unless there's some sort of ethical reason why you can't. And obviously the last two, I mean, there are lots of problems with these bottom ones that I put on the example, but you know, some of these are nation level, some are cities, some are vague about regions within a country. And then the last two are entire nations, and China and Russia are pretty diverse places. So, I mean, you've got to ask yourself, can a scale that large be useful in doing spatial meta-analysis? And we really do need to move to more precise labeling in our reports. All right, so complications in geocoding. Obviously, as I just implied, locations vary in precision. Points, latitude, and longitude are the most precise. I mean, you can pull out your phone right now and probably get a pretty exact latitude and longitude for your own location. Latitude, it's like the ladder going north-south. Longitude would be east-west. There are lots of little stories to tell about that. I'll avoid it in this talk. And also polygons can be quite precise. In geography, we talk about polygons. So like a census tract is a polygon. It's a bordered area that's integral to itself. A tiny nation like Luxembourg or Liechtenstein might be pretty precise. Or they can be quite granular, as I just illustrated on the last slide. And then there are other complications, like with trials, HIV prevention trials. We might know exactly where the study was done, but we can assume that they were drawn from the surrounding area. Probably we don't want a zip code. We probably want a little larger area just to optimize that. And then a couple of examples here. I mean, we know from research that people do make cardiac adjustments when they go to elevations, like this guy hiking, in a matter of weeks or months. I mean, at first it's a challenge to your cardiovascular system. You're breathing hard. After a while, your body gets used to it and develops and gets in shape. And so actually it's heart healthy to live at a higher elevation. And then we know that migratory patterns can change local cultures, and I'm trying to mention that later on in this talk too. I've got an example drawn from that literature. And then there's another complication, which is that some studies are multi-site, drawing on multiple areas. And so, if you can disaggregate the results, if they're reported separately by location, great. Otherwise, you're going to end up with a pretty coarse thing. Like it's averaged from 20 cities in the U.S. You might have to have a separate category for nation-level effect sizes. Now, what you do is follow rules to generate more precision for unknown locations. You could contact study authors to get exact locations. And sometimes you can find theses or dissertations that support a published version and might have much more information in them. And locations of authors on reports may be used, especially a senior author, because they tend not to move as much as junior authors. So that can be a way to judge. Other problems that happen from this and what you might have to do, you can gather all the related articles, or like I said, the theses or dissertations. Grant funding might provide clues, because usually these things are increasingly public domain too, or can be gotten by Freedom of Information Act requests. And they're going to disclose things that probably you can get there that might not be in reports. And then you can do sensitivity analyses if you track how exact the information is later, in case you want to tighten things up in your analyses and look at sensitivity analyses. So here are a couple of examples. So this one's nation-level coding. We were looking at some HIV prevention and adolescence database in this case. So the United Nations has a numerical code for each nation, and so you use that code, the formal code. And so now when you have some destination database you want to join with this one, they match up on that code one-to-one. And you would obviously, if you have it differently by time, you would match on not just the ID for the geocode, but also the time. A lot of spatial temporal meta-analysis doesn't bother with time, so it's not really temporal, I guess. Here's one that's in the U.S. I think this was also HIV prevention. This is the African American one. And so here we've used the Federal Information Processing Standard, FIPS code, associated with each county. So we were doing county level. Again, I argued that you don't want to just be right at the intervention site. You probably want a little bigger circle around it. So counties are convenient for that. And you see it's there in the database in two forms, one that's numeric and one that's alphanumeric, so the leading zero is automatically there. FIPS codes do have leading zeros when it's less than 5 actual places. You can have more specific polygons. I mean, you often see zip code level studies done and census tract data. I mean, these things have different uses. I mean, it's better for some things than others. So you kind of have to match to your needs. I mean, mostly with meta-analysis, I doubt zip codes or census tracts would be very helpful. Nations might be, but a big point is that when you get inside different nations, they have different systems for coding their polygons, their regions, and so on. So it becomes more difficult to model spatial temporally when you go outside a nation, which is one artificial reason why, like the Price et al. Study would have focused on U.S. studies. You can use geography software for geocoding. So ArcGIS, for example, has this. And I think there's some public domain software you can get this as well. You put in conventional names, address names, and they'll help you to get unambiguous latitude and longitude. And in turn, latitude, longitude can be mapped into those other codes, like I mentioned, zip codes and so on. You can literally plug in the address like this, and it gives you out what the actual latitude and longitude is. And then you'd use that to do the linking. Okay, one of my favorite places to go to characterize locales is Gapminder, so don't miss this. It's wonderful stuff. Hans Rosling was behind all this. It was so good, and his little Gapminder world has such wonderful visuals that Microsoft bought it. So I'm not sure how they're using Gapminder, but I'd be curious about that. Unfortunately, Hans has left us a few years ago, died from cancer. But if you want to see a 4-minute video with his dazzling modeling of data across 200 countries in 200 years, go to this particular video. It's been watched hundreds of thousands of times. I've shown it to my classes, nearly as many. Hans Rosling is really one of my heroes in the analytic world, and I miss him. Great sense of humor and dramatic showman. So on Gapminder, you can go out and find any number of videos that highlight Gapminder data, but they have, last I went on there, over 500 indicators, a lot of them from UN, from very reputable sources, about practically anything. I mean, there's carbon dioxide densities, which I didn't realize vary around the world, but they do. So it's ecological as well as, you can see on the top here, it's more demographic and economic. And other high-level predictors, census data. I mean, think about it. Keith Payne had a very interesting demonstration that the amount of slaveholding in 1860 for states in the United States is highly correlated, something like 0.75 with project implicit racial bias 150 years later. That's profound. And it's another demonstration that structural data really matter. You can go out and find increasingly polls that can be downloaded off the web. I mean, I've seen them with million plus cases in them. Now, if it's spatial, then you could use that in a spatial way. Spatial and temporal. American National Election Studies, you've seen me using those as a representative of voters anyway. General Social Survey. Sharp has files too, although I think it's the resources page that you'd want to look at, not the files page of them. I'm not sure what happens when you go to files. World value surveys are increasingly a great place, especially for nation level. And actually, recent versions of the world value surveys have included state for the United States participants. So again, you've got a way to gather a lot of information. And then this one will be really, truly meta, because why not use some of those indicators that are coming out of Gene Twenge's cross-temporal meta-analyses to, like, if you wanted to look at anxiety as a factor in studies in social psychology, why not use the means that come out of her models for undergrads? Boom. Or intelligence, for that matter. Marketers can be another place for it. I have bought databases from marketers that have space in them and have items asked in the surveys that I couldn't find anywhere else. So maybe you can buy data that would be relevant to your question. Here's the Sharp Research Lab page, so the resources tab, as I suggested. That's where you want to go. At some point, I'll have someone organize this so that we have a separate list for ones that have spatial information implicit in them. Some of them don't. Now, one last point about modeling and doing spatial temporal meta-analysis is that residuals from models have become they become even more interesting when they're connected to space and time. I mean, that's where people live. That's where you know something else about that space. So the general principle is this, that if you've got a bunch of related cases in the same area, that's spatial autocorrelation, and they are all residuals. It implies some sort of non-independence happening. And it might mean that you're missing predictors. Now, as a meta-analyst, I would say non-independence could be very, very serious spatially. I mean, I have friends who did HIV prevention research, for example, and some are still doing work in these areas, like in Milwaukee for 10 years, and then Atlanta for 20 years. So to some extent, you might be seeing spatial autocorrelation that's artifactual because the very same scholar is using the very same methods in the same place over time in a place. So if that turns out to be a factor, you might have located a way to identify a group effect, a researcher effect. And then qualitative inspection of outliers might lead to new prospective research. And I look for a good example of this, and we did some of this, but it would take too long to narrate, so I'm not going to. So here's another spatial analysis I did. It wasn't meta-analysis, but this is the idea. Here are significant outliers from a model with gun violence that we recently published. And what it's showing is all of these places have significantly misfit the model. They have more gun violence than they should have based on all the factors we put in our models. So now we'd want to go look at Orleans Parish in Louisiana, for example, or St. Louis City, Missouri, Baltimore City, Maryland. These are the places that have gotten a lot of attention, and we still don't understand them. Now, some cautions for spatial temporal meta-analysis. We should always be watching out for the ecological fallacy. What's the ecological fallacy? Is assuming that these broad level results are descriptive of individuals. Don't do that. In meta-analysis, we shouldn't do that either. We say members of a group, in the treatment group say, members in the treatment group did significantly better than members in the control group. It's not that every person in the group succeeded better. It's that enough of them did that we found a significant effect, or something like that. So be careful about ecological fallacy. The things that we model when we go to higher and higher levels are increasingly farther away from individual behavior, even if they're powerful. As I've noted, studies often fail to report locations precisely. This is a pet peeve for me. I mean, it makes me think that authors, when they publish, are assuming that their results generalize far and wide, beyond where the locale where they did their work. And in meta-analysis, we can check that. They often fail to report the time of the studies precisely, so those things go together. And then when we don't have disaggregation from multi-site and national trials, spatial meta-analysis is not going to be as informative. Then there's a more fundamental assumption in the spatial temporal meta-analysis, which is what location is the most important? Residence? Where people live? Is it where they work? Many people spend most of their working hours, at least during the work week, at work. So maybe the things that are affecting your phenomenon are there, not in their residence, maybe especially if they have to commute a long ways. And imagine a place like working in LA, at least pre-pandemic, and all the traffic jams, and it takes you 3 hours to drive there and 3 hours to drive back. Space starts to change when you look at particular examples like this. And leisure is another example too, because you might have a park in your neighborhood, and then your residence place is part of that. So where you spend leisure time, if you take long trips to certain locales, you're exposed to conditions there. Maybe when you go to the South Pole or the North Pole, I suppose, both places, you're exposed to higher UV, for example. And maybe then you're more prone to getting skin cancer later in life. So, there are all kinds of things that could be tracked if we had enough information in particular types of studies that are spatial. In meta-analysis, I doubt we're going to get anything that precise, so, but I'm just showing you the idea. Databases themselves may lack precision in time or space. I mentioned Gapminder not disaggregating within nations. They said a few years ago they were going to do it, but so far I haven't seen that promise out there. So sometimes when you're trying to get more precise for a database, you can hunt for databases for a long time. Sometimes you might have to make your own database to do the job. And then you already saw examples of this, that meta-analytic databases of studies may not cover space or time evenly. It's not an ideal world, it's kind of splotchy, I like to say, although it's not a technical word so far. And then I think you can see that spatial temporal meta-analysis is going to be more valuable as you get larger literature studies. So with time, we're going to see increasing abilities to use spatial temporal meta-analysis in clever ways. So I'm encouraging you to do it. So here's the last problem, which is confounding of moderators. So here are the price at all results, again, just focusing on girls. And we were asked to write a commentary on this piece, Christine Curley and me, my student. And we identified a few factors that were confounded with cultural sexism. So we've got the independent variable over here, and we didn't try to model the effects as we didn't ask for this part of the data to do so, and it would have become a longer paper if we had. So we kept it thinking, well, what are the confounds of cultural sexism, which is the independent variable in the analysis over here, with other things? And so one of our first hypotheses was that these places that are more sexist, look at this. We've got, the Deep South states where no trials occurred because they've got empty. We've characterized them as having empty dots. But that the places that are tighter are going to have more cultural sexism, and indeed this is a correlation that reached significance easily. And you can see the rest of the states. Go to the opposite end of the continuum if you want to see the opposite side. Oregon, Washington, California, all very loose states, also relatively low on cultural sexism. If you go and read our report, you've got the QR code over here again. That's a preprint of it that you'll find online there. If you go and look at it, we have two other features that we correlated as well. There's a few more in the technical summary if you read it. One of them was one I mentioned already, which is the project implicit racism implicit score is correlated not as strong as cultural looseness tightness, which comes from Gelfand, by the way, Michelle Gelfand. But cultural sexism and cultural racism are correlated at like 0.55. So, I should take that back. We use slaveholding as a proxy for the race effects in this case, and that was correlated 0.55. And then one other thing that Christine and I, entirely her work, is that sexual education practices, how strict they are, how open they are to the truth, I think a lot of people would say, is correlated as well with cultural sexism. So cultural states that are higher in cultural sexism have poorer sex education curricula. And I think the conclusion is, well, do we really know that it's cultural sexism at work here? without pitting them against each other, you're not going to have that. In fact, with a correlation this high, it might be hard to tease them apart, even with a relatively large database like they had, Price et al. In this particular meta-analysis. So, some conclusions. Obviously, I think spatial temporal meta-analysis deserves greater use, far greater use. And I'm always thinking about large meta-analyses that appear and whether it would be fun to analyze them with spatial temporal moderators. I mean, boom, you've got a timely meta-analysis looking at a bigger picture. But when you do it, I think you have to be aware of all the limitations that I just stated, and so you've got to go in with eyes wide open. And in fact, I might even add a suggestion to that: is go and find some colleagues who are experts in those broader things. I mean, go and get sociologists or economists, whatever domain is relevant to whatever you're doing, and bring them into the discussion. They'll have different theories than you will, and it might produce even better theory. And that's the last point, which is we might need to innovate with theory, because a lot of the ones we have, especially in psychology, are just between people's ears. Their perceptions of reality, perhaps, but not reality itself. So we don't know what actual effects reality is having on people, at least with contemporary research. Spatial temporal meta-analysis offers the chance to explore the limits of all that. And that's, again, a reason why it deserves greater use. So let's say goodbye to our geographer and leave you with a couple of discussion questions. Why is it that structural level predictors can have such high correlations with each other and with effect sizes? I think that's really profound. I suspect it has to do with aggregation, because we know aggregation helps with scaling. I suspect spatial aggregation does the same thing, but I'd like to hear your opinion about it, and I think there's a neat paper in that subject. If you're curious, I would like a collaborator. Second, does spatiotemporal thinking challenge conventional thinking in your discipline or sub-discipline? So think about your own theories. Are you thinking only about the body if you're a kinesiologist, or should you be thinking about the altitude where people are, or how clean the air is, stuff like that? Have a great day.